Third and final day on section 4.1, which is we've learned how to do antiderivatives. We've learned the difference between a particular solution to a differential equation and a general solution to a differential equation. So here we're going to look for a particular one given some specific information about its first or even its second derivative. So got this car, we're driving it along, we're kind of measuring how well it's accelerating, you know, we're kind of kicking the tires a little bit and seeing what we can do with it. And ultimately what we'd like to do is we'd like to figure out how quickly this car accelerates, and we'd like to find out how far the car travels in the 12 seconds that we're testing out. So two things that we're looking for here. So the acceleration of the car. Well, acceleration we know usually, whoops, I want to try to keep my colors consistent here. Acceleration we know as a of t, a of t. So according to this, the acceleration of this thing is going to be constant. So a of t is going to be a number. So if you think about what that means, if k is some number, and I didn't pick k for any reason other than math people like to use k's to represent some of these constants. If you wanted to find what k was, it would be nice to know some information about velocity. Because we know the velocity function is the antiderivative of the acceleration function, and ultimately the position function is the antiderivative of the velocity function. So here's what we've got going here. So we're starting, and according to this, it's going to take us 12 seconds to go from 10 feet per second to 40 feet per second. So if I was to sum that up, then we start measuring this thing. I'm going to call it the initial time 0. So my velocity at time 0 would be this 10 feet per second. And 12 seconds later, my velocity would be 40, again, feet per second. So that's information about velocity. And it says that we've got constant acceleration. So if you think about this, if we looked at this velocity function, if I ultimately thought about what's going to happen with this velocity function in a few seconds, this velocity function, well, what is the antiderivative of k? The antiderivative of k, well, if we're using t as our variable, what would I take the derivative of in order to get the number k? Well, it would be k multiplied by t. And oh yeah, if you're taking the antiderivative of k, not only would you have a kt, but you'd also have that constant of integration that we've been talking about. So the trick then, if you think about this velocity function, if we were to graph it out, what we really have is a function that's linear. This linear function for velocity, if you were to graph it out, we'd go from the point 0, 10 to the point 12, 40. And if you wanted to find what k was, k would be the slope of that line. So a really fast way to come up with what this constant acceleration is would be to find the slope of the line through those two red points we have. So our k is going to be, how about, let's see, 40, which is our last velocity, minus our initial velocity, which is 10, divided by our final time minus our initial time. And I think if we clean that up, our k is ultimately going to end up being 5/2 feet per square second. So we found our acceleration. So here it is. We came up with this acceleration. It's right here. We've got it. So then ultimately our velocity function is going to be this 5/2 instead of k times t plus my c. Well, how does one go about finding the rest of that velocity function? Well, according to the information that we were given, we were told that the velocity at time 0 was 10 feet per second. So if I know that v of 0 is equal to 10, then putting 10 where my velocity is and putting 0 where my time is, I can find out what c is. So take all of this information. My velocity function is 5/2 t, plus 10. So there's my velocity function. Okay, now what are we supposed to do? Are we done? No, because we were supposed to find stuff about distance. Well, as far as I can tell, if I wanted to find the distance the car traveled in 12 seconds, then I'd take the position that it was at after 12 seconds and I'd subtract the position that it was at the beginning. Well, where was it at the beginning? Well, the nice part about a scenario like this is we can measure from wherever we feel like. So if we said time 0 was when we were at 10 feet per second, then why not say that time 0 is our initial position? So if we say that, then really what we end up having is we end up finding that this is going to be a 0. So ultimately what we're looking for here is our S of 12. We're looking for our position. Again, I used the letter S to represent position. We're looking for our position at time 12. So before we can do that, we're going to need a position function. How do you find position function? S of t. Let's integrate that velocity function, again, with respect to time. 5/2 t plus 10. Integrate that thing. What's the antiderivative of 5/2 t? Well, we'd add 1 to the power and we'd get t squared. If we took 5/2 and we divided by 2, that would be the same thing as doing 5/2 times 1/2, which would mean a 5/4, plus, what did we take the derivative of in order to get 10? We must have taken the derivative of 10t in order to get 10. And then we need another constant of integration. Again, I should probably call it C2, but I'm just going to call it a different C because we've already found the red C was 10. Now we're going to be looking for the black C. Almost a world geography reference there. So what do we know? Well, we knew the velocity or the position at time 0 was 0. So using that information, let's put 0 in. Let's put 0 in for position. Let's put 0 in for time. And we're going to find out that that C is going to end up to be 0. So taking all of that information and putting it together, our position function, S of t, what's that going to be? How about 5/4 t squared plus 10t. So there's my position function. I've got it. Sorry about running out of room. So if I want to find S of 12, like I was asked to in the beginning of this problem, so S of 12 would be my 5/4 of 12 being squared plus 10 times 12. See, 12 squared is 144. 1/4 of that is 36. Times 5 is 180. 10 times 12 is 120. Add those two things together. In 12 seconds, that thing covers 300 feet.